Hello and welcome to Geometric Sequences Part 1. So, first things first, what does a geometric sequence look like? Well, we've seen arithmetic sequences, but now how do they differ? Well, I'm going to list some terms here, and I think you're going to see right away what is the difference. This is, of course, geometric, and the reason is because when you go from one term to the next, it looks like we're timesing by 2. We're not just adding an amount, we are timesing. And as soon as it's multiplication or division, well, welcome to the world of geometric sequences. Okay, we're not adding or subtracting an amount, we're multiplying by some number. So, a few things that are different here. This number that I'm multiplying by, that is called the common ratio. Remember what it was called for arithmetic sequences? It was called the common difference. Well, this is the common ratio. And in this example here, of course, it is 2. All right. The big thing we want to do with any new type of sequence is see if we can come up with some way of predicting or developing a formula for the nth term. Okay, so how can we do that? Well, I'm going to start off actually by clearing the page so I got more room. So I'm going to start off with term 1. Term 1 is just like it was with arithmetic. It's just A, just our first term. Okay, so our second term, well, we would take A and we would multiply it by our common ratio. And the common ratio is given the designation R, or the variable name R. Okay, so that's our common ratio. That's what we multiply by to go from one term to the next. The third term would be the previous term, which is AR, times by R again. So in other words, it would be A times R squared. Well, let's do one more of these, and then I think we can see what the pattern is. Okay, the fourth term would be, you take the previous term, so you go AR squared, and you multiply it by R again. So that's going to give us A times R cubed. All right, so what's going on here? How are we able to build a formula? Well, if you look at what we have here, it seems we are always going to have an A times some sort of an R, right? A times an R squared, A times an R cubed. So it's going to be A times R to the something. Now notice when n here was 4, the exponent was 3. When n was 3, the exponent was 2, and so on. So if the value is just n, then I want the exponent to be n minus 1. And that, ladies and gentlemen, is the formula for any given term if it is geometric. Okay, geometric sequence. All right, well, why don't we try an example and see what this formula can do for us. So I'm just going to clear the page here. And here we go with our first real example. So here is our sequence, 240, then I've got negative 120, then I've got positive 60, and so on. And here's what we want to do. We want to find the 7th term. Now, I understand if you wanted to, 7's a pretty small number, and we can see what's going on here. It looks like we're just dividing by negative 2 each time. You could probably just keep going and very carefully count your way along, and I'm sure you'd get the right answer. But what if this said the term 73 or something? That wouldn't be so easy to do. So I'm going to do this the correct way. So first thing I'm going to do is recognize, well, I know what A is, and it's 240, but I also need R, and I also need n. Well, n is easy, it's 7, because we were looking for the 7th term. But R isn't quite so obvious, so let's just figure out what R is. by going 240 times r, and that's got to give us the next term, which is negative 120. So I'm going to solve for r. I'm going to just divide by 240. So this is what r actually is. And I'm going to simplify that down. That is negative 1/2. All right, so I got A, R, and N. Now I'm going to put all that stuff into the formula and then work it out. So term 7. So that is A times R raised to the N minus 1. Okay, now we just got to simplify this very carefully. You don't want to make any mistakes at this point. Negative 1/2 raised to the 6. And this is going to be 240 times. Now, negative 1/2 raised to the 6, that's an even numbered exponent. So I'm not going to worry about the negative because I know I'm going to get a positive answer here. So on the top, I'm going to have 1. And on the bottom, 2 times 2 times 2 times 2 times 2 times 2 is 64. So here's what I end up with. It's 240 divided by 64. And I'm going to lower that down a little bit. You could put it into decimal form if you wish. I'm just going to divide the top and bottom by 16, and I get 15/4. So that's my final answer. That is what term 7 is. And I think that's where I'm going to stop with part 1 of these geometric sequences. And we'll come back with an example or two.